Ever wished your favorite blockchain apps could, like, just talk to each other?
Mm. Mm.
Imagine sending crypto from one platform to another, easy as sending a text.
Oh, wow. That
That's
was
the hopeful future of blockchain interoperability.
right.
And today, we're taking a deep dive into this white paper about a solution called Overledger.
Okay.
It's dense, but we'll unpack the good stuff, figure out what it means, especially for you.
Sounds good. What I find interesting is how this is bigger than just, making things easy for users.
Right.
We're talking breaking down the walls between blockchains, which could mean a flood of new innovation.
Totally. So the white paper starts off talking about single ledger dependency.
Yeah.
Basically, apps stuck in their own little blockchain worlds.
Right, exactly.
Like trying to order a pizza with a coffee shop loyalty card. Not really useful. What are your thoughts on this limitation?
It reminds me of the early internet days.
Okay.
All these separate networks, not really talking to each other. Remember trying to email someone not on AOL? Pain.
Yeah.
Overledger wants to be that universal connector,
Okay.
letting developers build apps that use the best parts of many blockchains at the same time.
So instead of one blockchain's rules limiting you, you could have an app using the speed of one, the security of another, maybe even the unique features of a third, all in sync.
Yeah, exactly.
Yeah.
Having that flexibility would be huge for developers. It lets them pick the best blockchain for each job. It's like putting together an all-star team of blockchains.
Love it, the best of the best. But how does Overledger actually do this? The white paper calls it a blockchain operating system. Is that as crazy as it sounds?
I think it's a good comparison, actually.
Okay.
Think about how your computer's operating system is like the mastermind.
Right.
It lets you run all sorts of programs without, dealing with the complicated hardware stuff.
Yeah.
Overledger wants to be that for blockchains.
Okay, so less about the wires, more about what we can do. Love it. The paper then goes on to describe a four-layer system.
Okay.
First, the transaction layer. This is where each blockchain does its own thing, right?
Exactly, yeah. Each has their own tech, ways of doing things, unique functions, all independent.
So it's like setting up the playing field, each blockchain having its own rules of the game.
Yeah, exactly.
Then things get interesting with the messaging layer. This is where Overledger steps in to translate all those different blockchain languages.
You got it. This layer is all about communication.
Okay.
Like, imagine trying to get anything done if everyone speaks a different language. Overledger's the universal translator, figures out what each blockchain's saying, and makes it understandable for everyone else. This is key for different blockchains working together.
That is a game changer. But with all that chatter, how does anything actually get done?
Right.
That's where the filtering and ordering layer comes in.
Yeah, this is where Overledger gets really smart.
Okay.
It's like a super efficient air traffic controller, making sure the right messages get to the right places in the right order.
So preventing total chaos?
Exactly. Without this layer, it'd be like drinking from a fire hose of blockchain data. Just overwhelming and useless. Overledger makes sure each app only gets the info it needs when it needs it.
This is already blowing my mind, and we're not even to the final layer. What's happening on the application layer?
This is where the magic happens, where we get to build the future.
Okay.
Thanks to all the groundwork laid by those other layers, developers can now create apps that talk to multiple blockchains without a problem. It opens up a whole new world of possibilities.
Okay, so we've got our foundation, our universal language, our traffic control. What does this actually look like for someone who's not a developer? What cool stuff could this unlock in the real world?
Okay, well, imagine a future where you can lend out your crypto on one blockchain and then use those same assets as collateral for a loan on another, all in one transaction.
Oh, wow.
Or picture a system that tracks goods across different blockchains, making sure things are transparent and secure at every step. The possibilities are, they're pretty amazing.
Okay, now you're speaking my language. This is starting to feel less like a technical deep dive and more like a glimpse into a really exciting future.
Yeah.
But I'm wondering, are there any downsides to all this interoperability?
Oh, that's a great question. And it's a super important one to ask with any new technology, actually.
Right.
We'll definitely look at potential challenges and security stuff a bit later.
Okay, sounds good. For now, let's keep this blockchain optimism going, and let's talk about what happens when we actually want to move assets between these different blockchains.
All right, sure.
We're talking transferring actual value between different blockchains, not just sending messages. That sounds really tricky to pull off, like, securely.
Yeah, it's definitely complicated, and this is where things get even more interesting. The white paper spends a bunch of time on cross-ledger transactions and how Overledger makes sure they happen without a hitch. They even mention the ACD properties, atomicity, consistency, isolation, durability,
Yeah.
those core principles of any reliable transaction system.
Okay, I'll be honest, those acronyms always make my head spin a bit. Break
Yeah.
it down for me. Why do those ACD properties matter for someone still, like, wrapping their head around all this?
Sure, sure. Let's say you're buying a digital collectible, right?
Hmm.
And you're using crypto from a different blockchain to do it.
Okay.
Atomicity means it's all or nothing. The transaction either fully completes on both blockchains or it doesn't happen at all.
Yeah.
No weird half-finished situations where you're out your crypto but you don't get the collectible.
Makes sense. I definitely don't want my digital stuff stuck in some blockchain void.
Yeah.
So what about those other properties?
Right, right. Consistency, that makes sure both blockchains end up with a correct and synchronized record of the transaction, like having two perfectly matched accounting books. Isolation, that means even if there's like a ton of other transactions happening all at the same time, yours is treated separately so nothing gets messed up.
So each transaction gets its own lane, no blockchain pileups.
Exactly. And then durability, that just means once a transaction's confirmed, it's permanently in the blockchain's history. No takebacks, no accidental deletions, which is, super important for building trust in any system that's handling valuable stuff.
Gotcha. Those A-side properties sound like kind of essential for any cross-blockchain future I want to be a part of. But how does Overledger actually guarantee all of that across all these different blockchains, each with their own, quirks and rules?
Well, this is where the two-phase commit comes in. It's a clever little system that Overledger uses to make sure things go smoothly, kind of like a safety check before any assets are actually moved.
Okay, tell me more about this safety check. I like safety.
So imagine you're sending crypto from blockchain A to blockchain B.
Mhm.
In the first phase, Overledger checks with both blockchains, A and B, just to make sure the whole thing's even possible. Do you actually have enough funds on blockchain A? Is blockchain B even set up to receive your type of crypto? If everything looks good, both blockchains give a preliminary, okay, we can probably do this.
Okay, so far so good. But what if one of them changes its mind?
That's where phase two comes in. Only when both blockchains have given their final approval does Overledger actually go ahead and execute the transaction. If even one blockchain throws up a red flag for any reason, the whole thing's canceled and you go back to square one. No harm done.
Wow, that's actually really reassuring. It's like having a super careful lawyer, going over every single detail before anything's signed.
Exactly.
Yeah.
And yet this two-phase commit process, it might sound a little complicated, but it's how Overledger can handle these complex transactions without putting anyone's assets at risk.
It's clear that someone put a lot of thought into making all of this work smoothly. Speaking of working smoothly, the white paper also talks about using something called order theory to deal with the challenges of, well, order and consistency. And this is where I might need you to put your teacher hat on because that went right over my head.
Haha, no worries. It is getting into the weeds a bit, but it's actually pretty cool once you get it. So picture this. You're trying to tell a story, but you've got sentences all jumbled up from different books. Each book has its own timeline, its own characters, right?
Okay, I'm following.
Order theory is kind of like the rules of grammar and logic that let you take those sentences, unscramble them, and put them back in an order that, makes sense and tells a clear story.
Okay, I'm listening.
So with Overledger, each blockchain is like one of those books. The transactions are like the sentences. They have their own internal order within their own blockchain. But when you're dealing with transactions across a bunch of chains, things can get messy, right?
Right.
Overledger uses order theory to make sure that everything lines up in a way that logically makes sense, even if the transactions are happening on blockchains that have completely different ways of keeping time.
So Overledger is like the ultimate storyteller, taking these different blockchain stories and weaving them into one big narrative.
Yeah, precisely. And that's super important for avoiding any weird time paradoxes when you're dealing with multiple blockchains. We want everything to make sense.
That makes a lot more sense now. So we've covered a lot the layers of Overledger, how it handles those cross-chain transactions, even touched on order theory a bit. But let's switch gears and talk about what this actually means for developers, the people actually building stuff. The white paper mentions this thing called the Blockchain Programming Interface, or BPI. What is that all about? So
Yes.
the BPI, these are the tools developers use to actually build on top of Overledger, right? Does it make things easier or harder for them?
Way easier from what I see in the white paper.
Okay.
Imagine having to learn a whole new coding language for every different blockchain you want to work with.
Oh, yeah, no thanks.
total nightmare.
Yeah.
But the BPI, it's like having that universal translator, but for code.
Yep.
Developers can use the tools and languages they already know to build their applications. And Overledger handles all the behind-the-scenes stuff, making sure everything talks to each other. This is huge. It makes blockchain development way more accessible.
So it's like those universal remote controls, one remote to rule all your gadgets.
Exactly, you got it. It gets rid of so much complexity, lets developers focus on the fun part, the building and creating.
That's what we like to hear. And the white paper even includes a code snippet, a little sneak peek at what the BPI can do. Anything stand out to you there?
It's cool how they actually show a cross-ledger transaction using the BPI. They're not just talking about it, they're showing you how it's done. Makes Overledger feel very real world, you know?
Yeah. Right. Like, we're not just theorists here. We're building the tools to make this happen. I like that. But even with all this cool stuff, gotta ask about the downsides. There's always downsides.
For sure, got to be realistic.
Yeah.
And the white paper does mention some potential challenges, things like blockchain bloat. And obviously security is a big one.
Yeah, blockchain bloat sounds messy. What is that?
Basically, as more stuff uses Overledger, the amount of data it has to handle, it could get huge. You know, kind of like when your inbox gets flooded with spam.
Oh, tell me about it. I know that feeling. So how do we stop Overledger from becoming a digital hoarder?
Well, the paper suggests implementing ways to filter out useless data, prevent that spamming. Kind of like how blockchains have those consensus mechanisms, right, to stop fraudulent transactions.
So a good spam filter, but for the blockchain.
Exactly. Trying to find the balance between being open and being secure.
Which leads right into the big one, security. We are talking about connecting different blockchains, each with their own strengths and weaknesses. Does this introduce any new risks that developers need to, like, watch out for?
Definitely something to think about.
Yeah.
But the white paper is clear that Overledger isn't trying to manage the security of each individual blockchain it connects to. It's more like building a super secure bridge between two fortresses.
Okay.
The bridge itself can be strong, but it doesn't control what happens inside those fortresses at either end.
So secure communication between blockchains, but not taking over their security entirely.
Exactly. Developers still need to be smart. Pay attention to the security of all the blockchains they're using, same as they would with any other blockchain project.
A shared responsibility kind of thing.
Yeah, you got it. And it's an area where ongoing research and development is going to be super important. As we connect more and more blockchains, we got to be ready to deal with any new vulnerabilities, stay ahead of the game.
Well said. Well said. This has been awesome, really mind-expanding diving into Overledger with you today. This white paper really paints a picture of a multi-blockchain future, and it seems like Overledger could be the thing that makes it all work.
I'm right there with you.
Mm.
And I think it shows how important it is to, bring different ideas together. The most exciting innovations, they often happen when different fields collide. Like here you got computer science, cryptography, even some theoretical math, all coming together to make something really groundbreaking.
It's like a delicious intellectual smoothie. But on that note, I think it's time for us to digest all this amazing info. Any final, thought-provoking questions you want to leave our listeners with? Something to ponder as they explore the world of Overledger.
How about this? If Overledger really works the way they say it does, it won't just be about connecting blockchains. It could connect, well, everything. All sorts of decentralized networks and protocols.
Oh, wow.
What if all these different decentralized systems could talk to each other without any problems? A true interconnected web of decentralization. What would that look like? What would be possible? That's something I'm really excited to see.
Now, that is a future worth thinking about. So to everyone listening, keep exploring, keep asking those good questions, and let's see what kind of amazing decentralized future we can build.